In this video, I'm going to show you how to name and write formulas for molecular compounds. So molecular compounds are made of just nonmetals. The smallest piece is a molecule. It can't be held together by opposite charges of attraction like ionic compounds can. And they don't have charges, so you can't use them to figure out how many there are of each atoms. Molecular compounds are actually easier though. Remember, in an ionic compound, we had to use charges to determine how many of each. You need to know how to figure out the number of the charge. You also may need to crisscross numbers, and you could mess up there as well. Molecular compounds, I think, are actually a little easier. The name tells you the number of atoms. We use prefixes to tell you the exact number of each element that's present. The only thing is you need to know these prefixes. This isn't anywhere on your reference tables. This is just something you need to know. So write these down in your notebook and study them. A lot of them are pretty intuitive, but some of them you may need to study a little bit. So the first one, one, if you have one of an element, we use the prefix mono. Think monocle is like glasses with only one lens. If you have two of an element, we would use the prefix di. If you have three, it would be tri. If you have four, it would be tetra. That one's a little weird. You may not have heard of tetra before. Five is penta. Think pentagon, has 5 sides. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona, and 10 is deca. We won't go any higher than 10. So to write the name, you need to write 2 words. So you're going to write the prefix in the name for the first element, and then the prefix in the name for the second element of the molecular compound. There's 2 exceptions though. We don't write the prefix mono if there's only one of the first element. You just skip it. You just name the element. And the other thing is normally we don't have double vowel sounds when writing names. If you have an O next to an A or 2 O's next to each other, we end up dropping one of those. You'll see in the examples we do. So let's practice by naming these. So my first one, N2O, I have 2 nitrogens. So remember, we always want to write prefix name, prefix name. So the prefix for 2 is di. The name of the first element, nitrogen, so we'd write dinitrogen. And then we're on to the second element. There's 1 oxygen, so the prefix for 1 would be mon, be mono, but you see we're going to drop 1 because the element's name is oxygen, so it would just be monoxide, dinitrogen monoxide. It would just sound a little silly if we said dinitrogen monoxide. So there's that exception there. All right, the next one, NO2. So the prefix for 1 would be mono, but remember the other exception is we don't write mono if it's the first element. So for this one, we'll just write nitrogen. And then we do the prefix and name for the second element. So I have 2 oxygens. So the prefix for 2 is di, and the element is oxide. So nitrogen dioxide. Next, Cl2O7. So the prefix for 2 is di, Cl is chlorine. The prefix for 7 is hepta, but we're going to drop the A because the next element begins with a vowel, oxygen, and the second element you always write with an "ide" ending, so it would be heptoxide, dichlorine heptoxide. Next, we have CBr4. So the prefix for 1, we have 1C would be mono, but we don't write mono if there's only one of the first element. So again, we're just going to write carbon. Then I have 4-bromine. So the prefix for 4 is tetra, and bromine becomes bromide, carbon tetrabromide. Next, I have CO2, no prefix if it's 1 on the first element, so again, just carbon. And I have 2 oxygens, so the prefix would be dioxide. Now there's a case where I have 2 vowels next to each other. That's okay. I can't have 2 O's or an A and then an O. And the next one, BaCl2. It is barium chloride. And you might be saying, well, why didn't she use a prefix? Why isn't it barium dichloride? And that's because it's ionic. So I tricked you there. And I'm not tricking you to be mean. I am tricking you to prove a point, to show you that when we eventually take quizzes or tests on this topic, they're not going to be in neat little categories like this where we answer all questions on ionic compounds and then then a section on molecular compounds are all going to be jumbled up. So you need to think before you name a molecule, um, is this a metal and a non-metal? Like barium is a group 2 metal and chlorine is a halogen, a non-metal. If it's ionic, your brain needs to shift to the ionic naming system we talked about in the earlier videos, where you just name the cation and then the anion with an "ide" ending and maybe a Roman numeral. If you have two nonmetals, like all the other examples above, you use the prefixes that we're learning in this video. Okay, we also need to be able to go in the opposite direction from the name to the symbols. So diphosphorus pentoxide. So di means I have 2, and phosphorus means my first element is phosphorus. So P2, and then pentoxide means I have 5 oxygens. So P2O5. Next, we have tetraiodine non-oxide. So the iodine tells me it is I. Tetra tells me I have 4 of them. The oxide tells me my next element is O, and the non tells me that I have 9 of them. So I4O9. Next, we have sulfur hexafluoride. This is a very interesting molecule. We'll talk more about it in class. I have a fun video to show you on sulfur hexafluoride. Try to remind me. So sulfur is just S. I only have 1 of them. And then hexafluoride tells me that my next element is fluorine, and I have 6 of them. Next is nitrogen trioxide. So nitrogen is N, and the trioxide tells me I have 3 oxygens. Next, I have carbon tetrahydride. So carbon is C, and tetra means I have 4, and hydride is hydrogen. So I have 4 hydrogens, CH4. Next is phosphorus trifluoride. So phosphorus is P, fluoride is F. I have 3 of them because that prefix tri means 3. So PF3. And the last one is aluminum chloride. This is another ionic compound, so you need to recognize that aluminum is a metal, chlorine is a non-metal. So I would write the symbol charge, and crisscross. Aluminum is a 3 plus charge because it's in group 13. Chlorine is a 1 minus charge because it's in group 17. A 3 plus does not balance out a 1 minus, so I need to crisscross the charges. I'll bring the 3 over to this side, and the answer is AlCl3. So to write the name of a molecular compound, you need to use the 2-word naming system. You write the prefix in the name for the first element, prefix in the name with the "ide" ending for the second element. You have to just know these prefixes. They're not on your reference table directly. It is just going to require you studying until you know them. Most of them are pretty intuitive. Again, prefix name and prefix name with an "ide" ending is how we name molecular compounds. And to write the formula from the name, write the element symbol, then the prefix will tell you how many of that element there is, and then you just write it down. But remember, this by itself is pretty easy. Where this gets challenging is when we jumble all these questions together. You really need to slow yourself down in this chapter and stop and think, is this an ionic compound? Do I have a metal and a nonmetal? If so, then you use the ionic naming system. If this is a molecular compound and you have 2 nonmetals, then you need to use your prefixes. And if you're struggling with this at this point, that's okay. We have a lot of practice left to go. And if you're doing great, that's great. And the more practice we do in class, just the better you'll get at it. And most kids by the end of this chapter really do well with this naming thing. And you're going to know how to name these compounds as we move on to other chapters, where I just can give you the name and you're going to have to turn them into the formulas to answer the questions on something else. So if you have any questions at this point, please write them down and let me know in class. And remember, if you're struggling at this point, we have a lot of practice left to go.